Welcome back and thank you for joining. We'll continue with some more trig identities. So here we go. We have example number 2a. We have cosecant x divided by secant x. And we want to prove that it equals cotan x. So first we have to pick a side. We want to pick the side that has more terms, which means that more opportunities to transform it and to simplify. Now, as you can see here, you have two different trig ratios, and on the right side, we have only one trig ratio, so obviously the choice will be the left side. So we're going to start working with the left side, and I always like to write the left side the way it is, cosecant of x divided by secant of x. So remember, we are trying to get to cotan x. One of the strategies that we usually like to apply is convert everything into a sine and cos, because sine and cos work very well together. So cosecant is the reciprocal of sine. So instead of cosecant x, we'll write 1 divided by sine of x. Secant is the reciprocal of cosine, so 1 over cosine x. So now we are dividing. So once you replace terms, then you simplify to see what they look like after the replacements. So we have 1 over sine of x. The division will turn to multiplication, and that will flip the fraction that is in the denominator, and it will change it to cosine divided by 1. So the other way around. And as you can see in here, we have multiplication of two fractions. So we say numerators together, denominators together, will multiply to give cosine of x divided by sine of x. And cos divided by sine, keep an eye always on where you want to get to, cotan x, that would equal cotan x exactly, which means that the left side of this identity has become exactly the same as the right side, so the identity is proved. Let's move on to another example. This time we have sine squared plus cosine squared equals 1 plus 2 sine x cosine x. If you decided to go for the left side, and why for the left side? Because we can expand the power of 2 for this binomial. And we know that the expansion will bring sine squared and cosine squared here, so that can hopefully help us simplify and get to the right side faster. So we're going to get started with the left side, which is sine squared x plus double sine times cosine, and then plus cosine squared x. So you see that we have sine squared and cosine squared in this expression. They together will combine to give number 1 based on the Pythagorean identity sine squared plus cos squared equals 1. So 1 plus 2 sine x cosine x. Oh, that was very quick actually. That is exactly equal to the right side. So we're going to say that identity is proved. Let's move on to one more example. This time we have secant squared plus cosecant squared is equal to the product secant and cosecant. So either side would be fine to work with. I would choose the left side first and check and see if I can make it look like the right side. And that is because we have the exact same terms in both sides of the identity, but here we have them in the form of two separate terms, which means that there is simplifying that can happen by adding the terms together and hopefully getting to a single term that looks like the right side. So let's get started with the left side. So again, I'm going to write the left side as is. So that is secant squared x plus cosecant squared x. So one of my most favorite strategies is convert everything into sine and cosine and let them work together. So secant is the reciprocal of cosine, so 1 over cosine squared x, plus cosecant is the reciprocal of sine, so 1 over sine squared x. Now we have two fractions that we're trying to add, which means that we have to first find the lowest common denominator. In this case, lowest common denominator is sine squared times cosine squared. So that would be equal to 1 over cosine squared x will need to be multiplied by a sine squared. So to make it the same as the lowest common denominator. And because of this, then we'll multiply the numerator by sine squared as well. And now we have 1 over sine squared x. The sine squared x here, we're going to need the cosine squared. So we'll multiply by cosine squared x, both numerator and denominator. So now the denominators are exactly the same. So we can bring the entire expression into a single fraction. So sine squared times cosine squared. And the term that we have in the first fraction is 1 times sine, which is sine squared. And the term in the second fraction is cosine squared, so plus cosine squared x. Sine squared and cosine squared are joined by the Pythagorean identity, so they equal 1. And then denominator has sine squared x cosine squared x. It seems that that's all I could do to simplify the left side. So now it's time for me to take a peek at the right side to see where I am and how far I am from the other side of the identity. So what you see in here is 1 over sine squared over cos squared, and what we have in here is cosecant and secant. So one step that we can think of in this case, and I want you to think about it right now, is splitting this product into 2. And I'm going to write it in different ways just so that I can explain different ways of seeing it, and then you pick the one that is easier for you to see and understand. So the idea is that we can write this as 1 over sine squared x times 1 over cosine squared x. And 1 over sine squared is the reciprocal of sine or cosecant squared x times the reciprocal of cosine, which is secant squared x. And now we have arrived to the right side, and we're going to say that the left side equals the right side, so the identity is proved. Now, let's move on to our last example for the lesson. We have cotan squared x equals cosine squared over 1 minus cosine squared x. You probably have already figured out we're working with the right side. And the reason why is because the right side has more terms that we can replace. So as you can see, we have cosine squared in the numerator and 1 minus cosine squared in the denominator. We have powers of 2 on the right side and power of 2 on the left side. So the power of 2 is probably a good thing to have. Let's put it that way. Now, when you think about cotan squared, cotan is cosine squared over sine squared. So cosine squared is already in the numerator, so probably we're going to keep that in for now because we don't need to replace it by 1 minus sine squared. It's in the right spot because of the cotan. But we will put more thoughts into the denominator, and we're going to say that the cosine squared is left the same, but 1 minus cosine squared can be written as sine squared x. So cos over sine is cotan. If they're both squareds, it means that we have cotan squared x, and this was even easier than we thought it would be. Voila, this is the end again. So the right side is equal to the left side. So these were examples for the first part of the trig identity lessons. In the second part, we'll practice more questions and we'll embrace some more challenging questions, and we'll discuss everything in class, obviously. So keep practicing. Try as many questions as possible. Do not give up easily, but if things get very hard, just skip ahead, do something else, and then try to come back to the same question. It very often happens that in trig identities we may be working on it for an extended period of time, and the answer just doesn't come right away. And that is not that they're impossible to conquer, it's just that sometimes we need to find the right moment to see the right formula, because it is like a small little puzzle that we have to prove in one way or another. So I hope you found instructions useful again, and thank you for learning with me. Bye for now.